6 people die from alcohol poisoning every day in the United States. Not from car crashes, not from liver failure after decades of drinking, from a single night. The average blood alcohol concentration recorded in fatal cases hovers around 0.355%, more than 4 times the legal driving limit of 0.08. 3/4 of the people who die this way are between 35 and 64 years old, and 3/4 of them are men. The number that should stop a person cold. This isn't a college problem. It never really was. That contradicts almost everything the public has been told to picture when it hears the phrase alcohol poisoning. The image is a dorm room, a red cup, a 19-year-old who drank too fast at a party. That image isn't wrong exactly. The National Institute on Alcohol Abuse and Alcoholism estimates roughly 1,519 college students between 18 and 24 die from alcohol-related unintentional injuries every year. And binge drinking on campuses remains a documented and serious pattern. But it is incomplete in a way that matters. A CDC analysis of national death records from 2010 through 2012 found an annual average of 2,221 alcohol poisoning deaths among people 15 and older, and the demographic center of that number sits squarely in middle age, not adolescence. The story the culture tells about this danger and the story the data tells are two different stories. That gap is where this one begins. Subscribe if that gap surprises you, because it gets stranger from here. Start with what alcohol poisoning actually is, mechanically, because the phrase gets used loosely, and loose language costs lives here specifically. It is not a synonym for very drunk. It is a specific physiological event. Blood alcohol concentration rises faster than the liver can metabolize it, and at a high enough level, ethanol begins suppressing the parts of the brainstem responsible for breathing, heart rate, and temperature regulation. Forensic toxicologist Kurt Dubowski's widely used clinical staging chart, still referenced in emergency medicine and toxicology training today, maps the escalation in blunt terms. Confusion and disorientation begin around 0.18 to 0.30%. Stupor, vomiting, and loss of motor control follow between 0.25 and 0.40. Coma, depressed reflexes, and impaired circulation and respiration begin around 0.35 to 0.50. Above 0.45, death from respiratory arrest becomes a live possibility rather than a remote one. Those ranges overlap on purpose. The chart isn't describing a smooth ramp. It's describing a system that can fail unpredictably because body weight, tolerance, food intake, and individual metabolism all shift where a given number becomes lethal for a given person. The historical context here isn't decorative. It explains why the public conversation and the clinical reality drifted apart in the first place. Systematic toxicological staging of alcohol intoxication is a mid-20th century development, built largely out of forensic pathology and drunk driving enforcement, which means the entire framework was constructed to answer a legal question: is this person too impaired to drive? Rather than a medical one: is this person's brainstem currently at risk of shutting down? Those are not the same question, and the gap between them has never fully closed. The 0.08 legal threshold that defines impaired driving in most U.S. states sits nowhere near the 0.30 plus range where the CNS itself starts failing. People calibrate their sense of danger against the number they know. The number they know isn't the one that kills them. Here is what happens inside the skull once concentration climbs past the point where behavior is the concern and physiology becomes the concern. Ethanol is a central nervous system depressant, and it works through 2 neurotransmitter systems simultaneously, pulling in the same direction from opposite ends. It potentiates GABA-A receptors, the brain's primary inhibitory signal, making neurons less likely to fire. At the same time, it suppresses NMDA glutamate receptors, the brain's primary excitatory signal, making the neurons that do try to fire less effective when they do. Research summarized in Frontiers in Neural Circuits describes this as a system-wide shift in the excitation-inhibition balance toward inhibition, occurring across the reward circuitry, hippocampus, and hypothalamus simultaneously. The brain isn't being shut off in one location, it's being dialed down everywhere at once, and the dial doesn't stop at relaxed. There's a more specific finding worth sitting with because it explains a phenomenon almost everyone has either experienced or witnessed and almost no one understands: the blackout. In 2011, Washington University School of Medicine researchers Yukitoshi Izumi and Charles Zarumsky, publishing in the Journal of Neuroscience, identified the mechanism. They found that high alcohol exposure doesn't kill hippocampal cells outright, as had sometimes been assumed. Instead, it triggers a cascade in which NMDA receptors are first inhibited, and then, paradoxically, other receptors are activated in a way that causes neurons to produce steroids that block long-term potentiation, the cellular process memory formation depends on. The hippocampus keeps functioning, it simply stops being able to write anything down. A person mid-blackout can hold a conversation, walk, argue, drive a car, and none of it will exist afterward, because the recording mechanism, not the behavior itself, is what got switched off. That's the memory system. The system that actually kills people is one region over and several degrees more serious. The brainstem controls breathing, heart rate, and temperature regulation, the functions that don't wait for conscious permission to happen. Long before alcohol touches the parts of the brain responsible for judgment or coordination in any lethal way, the sequence that produces death has already started elsewhere. Respiration slows, then becomes irregular, then, past a high enough concentration, stops. A breathing rate under 8 per minute is treated clinically as a medical emergency in its own right. Heart rate and blood pressure fall alongside it. Core body temperature drops, producing a real hypothermia risk even indoors, even under a blanket, because the body's thermoregulatory feedback loop is one of the systems being suppressed. And the gag reflex, the automatic mechanism that prevents a person from choking on their own vomit, goes with it. This is the actual mechanism behind the majority of alcohol poisoning deaths that don't involve respiratory arrest outright: aspiration. A person vomits while unconscious, and the reflex that would normally clear the airway simply doesn't fire. Here's the complication, and it's the one that makes "just let them sleep it off" a phrase with a body count attached to it. Blood alcohol concentration does not stop rising the moment a person stops drinking or loses consciousness. Alcohol still sitting in the stomach and small intestine continues to be absorbed into the bloodstream for a period afterward, while the liver, which can only process roughly 1 standard drink per hour, a rate that doesn't speed up no matter how much alcohol is present, works at a fixed pace regardless of how much is still coming in. That means a person can pass out at a BAC that looks survivable and wake up, if they wake up, at one that isn't. The danger window isn't the moment of loss of consciousness, it's the hours after, unmonitored, while concentration keeps climbing on its own momentum.
If you're the kind of person who wants the mechanism, not just the warning label, stick around. The next part is the one that gets left out of every after-school pamphlet on this subject. Now, the counter-argument, because it deserves to be taken seriously before the next claim gets made, someone could reasonably point out that fatality thresholds vary enormously by individual. Tolerance built through chronic heavy drinking measurably shifts where impairment becomes visible, and functional tolerance is well documented in the literature. A person with significant chronic alcohol exposure can present as coherent, ambulatory, even verbally sharp at a BAC that would leave a naive drinker unconscious. That's true, and it matters clinically. It's part of why alcohol use disorder complicates emergency assessment. But it's a claim about the behavioral presentation of intoxication, not about the underlying physiology. Tolerance changes how impaired a person looks. It does not raise the blood alcohol concentration at which the brainstem's control over respiration and circulation begins to fail. The subjective experience adapts. The lethal threshold, broadly, does not, which is precisely why experienced drinkers are represented among poisoning deaths at rates that surprise people who assume tolerance functions as protection. It doesn't. It functions as camouflage. This is also where the demographic data stops being a curiosity and starts being an indictment of where public attention has gone. The CDC's 2010-2012 analysis found that the highest age-adjusted alcohol poisoning death rate by race and ethnicity belonged to American Indian and Alaska Native populations at 49.1 per million, more than 5 times the national rate. State-level rates ranged from 5.3 per million in Alabama to 46.5 per million in Alaska, a spread that tracks not just drinking patterns but access to emergency care, rurality, and the distance between a person in crisis and a hospital that can intervene before respiratory arrest becomes irreversible. None of that shows up in the party photo version of this story. All of it shows up in the mortality tables. Zoom out one more level because the acute poisoning number, real and under-discussed as it is the smallest piece of a much larger pattern. The CDC's most recent multi-year analysis found that deaths from excessive alcohol use, broadly including chronic conditions like liver disease and alcohol-attributable cancers, alongside acute poisonings, rose from an average of 137,927 per year in 2016-2017 to 178,307 per year in 2020-2021, a 29% increase in roughly half a decade. Deaths among women rose faster than deaths among men over that window, 35% versus 27%, a divergence researchers have connected to a longer-running trend of women's drinking patterns converging with men's over the past 2 decades. About 4,000 of the annual total involve people under 21. Here's the observation, and it only gets made once. A species that spent the last decade meticulously tracking opioid overdose numbers in near real time somehow allowed the substance sitting in every refrigerator in the country to kill more people faster with less public alarm attached to each individual death. Back to the data. The historical parallel worth naming directly, this is not the first time American drinking patterns have shifted sharply enough to move the mortality numbers, and it will not be the last. Consumption spiked during Prohibition's aftermath and again during economic contractions throughout the 20th century, each time producing a corresponding rise in acute alcohol-related harm, a pattern epidemiologists describe as drinking behaving like a stress-responsive variable at the population level, not a fixed cultural constant. The 2020-2021 increase lines up chronologically with a period of widespread isolation, disrupted routines, and reduced access to in-person medical and behavioral health care, conditions researchers cite as plausible contributors alongside expanded alcohol delivery policies that stayed in place after the acute phase of the pandemic ended. Correlation isn't the same as a fully established causal chain here, and the CDC's own reporting is careful to not overclaim a single driver. What the historical pattern does establish is that these numbers move with social conditions in ways that make them predictable in hindsight, and so far not particularly preventable in advance. There's a longer-term consequence that gets almost no attention relative to acute death, and it deserves its own moment before the close. Survivors of repeated severe alcohol exposure, not necessarily a single poisoning event, but the chronic heavy drinking that often surrounds it, are at risk for Wernicke-Korsakoff syndrome, a form of permanent brain damage driven by thiamine deficiency that alcohol both causes and accelerates. It presents first as confusion and abnormal eye movements, and without prompt treatment, it can progress to a lasting inability to form new memories, a person cognitively frozen at the moment the damage occurred, still able to speak, still able to reason about the past, unable to add anything new to it. The acute event makes the news, when it makes the news at all. The chronic damage in survivors generally makes nothing. So where does the data actually point once the party photo version of this topic gets set aside? It points toward a hazard that is mechanistically well understood: the GABA and glutamate pathways, the brainstem's respiratory and thermoregulatory control, the absorption lag that keeps concentration climbing after drinking stops, and a public risk perception that is aimed almost entirely at the wrong demographic. The people dying are disproportionately not the ones being warned. What remains genuinely unresolved is why 4 decades of task forces, public health campaigns, and a fairly complete physiological picture haven't bent the mortality curve downward. Whether that's a failure of messaging, a failure of access to emergency intervention in the geographic areas hit hardest, or something more structural about how a legal, culturally normalized substance resists the kind of alarm that drives policy change for anything else that kills at this rate. A blood alcohol concentration is just a number until a brainstem stops answering to it. 6 people a day find that line without ever knowing it existed. If you want more videos like this, subscribe.